Okay, so I want to talk a little bit about linear transformations. Okay, so first off, I want to talk about just the general idea of what a linear transformation is. Okay, so let's just say we start off with a vector. Okay, and let's say we have this vector and it's, I don't know, 3, 2. Okay, let me use the little right notation here. Okay, a linear transformation takes a vector, okay, and just changes it to another vector. Okay, and it can move it left, right, up, down. It can spin it, whatever. So maybe it changes the vector to be one that looks like this, okay? And that vector might be -3, 2, okay? So, and all I've done is I've turned it going the other direction. I've reflected it, okay? And I've moved it up and I've moved it to the left, okay? That's all linear transformations do. It takes, in general, straight lines and maps them to straight lines. And this is really important, especially like in graphics and stuff, right? If you're thinking about games, and imagine somebody, a character walking down a street, okay? All of the points and stuff are represented by vectors, okay? And as it walks down the street, those vectors have to move. The buildings have to move, right? Um, so that's all a linear transformation is. It's a very special transformation where straight lines stay straight lines. Okay? We can't take a straight line and turn it into a circle. Okay? Not with a linear transformation. There are transformations that do that, but not a linear one. Okay? So the end result is what we call the image. Okay? So this is the image of 3, 2. Okay? Now we've got several questions and stuff that do it. So let's just pretend for a second, okay, that I've got this linear transformation that's given by this matrix. Okay, I'm going to call that A. Why not? Okay. Kind of the equation looks like, A times vector X is looks like, equals some other vector. Mm-hmm. So let's just see what would happen to a vector under this transformation. Okay, so I'm going to graph these two so we can kind of see what goes on. Okay. And let's just take then the vector, well, let's just stick with 2, 3. Okay, so let me draw that in here. So we're starting off and we have the vector 2, 3. That would be this vector right here. Okay. All right, so all we do is it's just matrix multiplication. Okay, so that's 6, 12, 0, 15. So that's the vectors 12, 15. Okay, I better make my axis a bit bigger for that, huh? So that image would be this vector that goes way up here. Okay, it's stretching it really far. Okay, and it looks like it's rotating it maybe just a little bit too. Okay. All right. So anyway, that is the image. Okay, that's what we mean. This is the image of 2, 3. Now suppose I want to say, well, what vector then gets mapped to the point, why don't we say a -6, 5? Okay. What vector has the image -6, 5? Or what gets mapped to -6, 5? Those are kind of the two most common phrases that you see. Well, this is just a system of equations then that we can solve, because if you multiply this out, this is 3x plus 2y, and that has to be equal to the negative 6. And then we have 0x plus 5y has to equal the 5. Okay? And I need to solve this. Well, this is actually really easy to solve because the second equation here tells me that y has to equal 1. So I can just substitute that in and go, okay, well, 3x plus 2 equals negative 6. So 3x equals negative 8. X is negative 8 thirds. So the vector that maps to that would be the negative 8 thirds 1. Okay. Don't make the linear transformations any more complicated than that. These actually become really super important later on, because when we get into talking about vector spaces and stuff, when you get into that sort of stuff, we can use linear transformations to find things about the dimensions of the vector space, and how to change to different bases and things like that. So these ideas are important. So right now, this is just kind of introducing a tool that we're going to use later on in our math career stuff. You may see that in this class when we talk about vector spaces. Okay. So hopefully this helps just a little bit. Um, Looking at something real quick. Yeah, so in week 7 is when we'll get into the vector spaces and subspaces and things like that. So these linear transformations, you'll definitely be using some of these types of things later on, okay? Anyway, hope this helps a little bit. I know it's just a quick, short video, but there's really not a whole lot to the linear transformations, because right now we're not proving they are and things like that. We're just kind of using them, okay?